Nalla Narsimareddy, Education Society's group of institutions, integrated campus. This is Dr. G. Subbarao, Professor, Department of Civil Engineering. I welcome all the civil engineering students and concerned persons for this session. In this session, I am going to explain about color, streak and hardness, which are a part of physical properties of minerals. The objective of this session is, by studying the color, streak and hardness, a civil engineer can easily identify the minerals to the maximum extent. Let us start the topic: color, streak and hardness. Color. Minerals show a great variety of colors and it is very easy to identify by studying their colors. The colors are two types. One is dark colored minerals and the other one is light colored minerals. That means color wise minerals can be divided into dark as well as light colored minerals. Why there is a differentiation between the color, that means dark and light? This is because mineral colors are generally related to the spatial arrangement of the constituent atoms. Sometimes the impurities present in the minerals are both, the arrangement of atoms as well as presence of impurities, make changes in the color of a mineral. Hence, color wise minerals are divided into dark colored minerals and light colored minerals. For example, whatever we discussed, the internal arrangement of atomic structure or the presence of impurities. See, the diamond is colorless and transparent, whereas graphite is black and opaque, even though both contain carbon. So the chemical composition of diamond is carbon and the graphite composition is also carbon. This is related to atomic structure. Though the chemical composition is same in both the cases, because of the internal arrangement of atomic structure, the carbon, the presence of carbon, made a mineral as diamond and another as graphite. If we study the color related to the presence of impurities, pure quartz is colorless and transparent. But if some impurities are present, that quartz exhibit as a pink color or purple color. That means because of the presence of impurities, we can call it as pink quartz or purple quartz. That is how the colors are shown by different minerals due to the internal arrangement of atomic structure and the presence of impurities. See, the calcite and feldspar and quartz, all the minerals are exhibiting in different colors. That's why it's somewhat difficult to identify only based on color, because in some case calcite exhibits white color, in some cases it exhibits in a pale or dark brownish in color. This is because of the internal arrangement of the atomic structure or the presence of impurities. In the same way, feldspar can be seen in pale pink color, otherwise gray in color. That means there are two colors can be seen here, and similarly quartz can be seen rose quartz as well as milky quartz here. And some of the minerals which are shown here, kyanite, chlorite, alvin, which are very peculiar. Alvin always occurs in dark green, and the kyanite, of course, which is characterized by bluish color, and chlorite, grassy green color it appears. So in some cases these colors can easily give the clue for identification of a mineral. And similarly, hornblende, coal, garnet also can be identified easily with their colors. See, all garnet, reddish garnet, in addition to form, that means shape, so which can be identified very easily. Coal, its color is totally dark and black in color, so that it can be easily identified. And another physical property is streak. What is the meaning of streak? The streak of a mineral is defined as color of its powder. Many minerals exhibit a different color in the powder form compared to the form of mass. So the difference between color and streak is, in case of color is the body of the mineral, whereas streak is the color of its powder. This is the major difference between color and streak. So the powder of the mineral is obtained by scratching the mineral with a knife or rubbing on a unglazed porcelain plate, that is called a streak plate, so that we can collect the color of the powder of the mineral, that is called streak. So with the help of streak plate we can identify the streak of that particular mineral, that means color of its powder. Most transparent minerals show white streak. Colored minerals show dark color streak. This is to be kept in mind very clearly. Transparent minerals show white streak, whereas colored minerals show a dark color streak. Some of the minerals are shown here very clearly. There is a streak plate and each mineral cinnabar, how the mineral is looking, and how the powder of the mineral, that is a streak, is seen very clearly on the streak plate. And similarly pyrite, and also other minerals, calcite, hematite, feldspar, barytes, all the minerals are shown. Body color can be seen very clearly here, and at the same time streak of the mineral, that means powder of the mineral, is also seen here. Coming to another property is hardness. What is meant by hardness? Hardness may be defined as the resistance offered by the mineral to abrasion or scratching. For example, if a mineral specimen is considered as muscovite, when it is tested on the Mohs scale of hardness, it should not be scratched by gypsum or by calcite. So Mohs hardness scale can be seen in the next slide. Until that, we just remember muscovite is not scratched by gypsum and can be scratched by calcite. That means its hardness is between gypsum and calcite. The composition of the mineral appears to have less influence over the hardness. For example, graphite and diamond, which possess the same composition. What is the composition? It is carbon, that means C. But atomic structure is different in both the cases. So, these two, exhibit hardness also in a different way. Graphite is extremely soft, whereas diamond is extremely hard. That's why diamond hardness is more, that is on Mohs hardness scale, it is designated as 10, whereas graphite is extremely soft, it can be correlated with talc, which is designated as hardness 1. That means graphite is very close to talc. This is called Mohs hardness scale. In 1982, a mineralogist, Mohs, proposed a relative scale for hardness of minerals for easy identification. He has made a set of 10 references which are used to determine the hardness of any unknown mineral. So, a unknown mineral is taken and that is to be abrased by two minerals so that we can calculate the hardness. Hence, talc hardness is calculated as 1, gypsum 2, calcite 3, fluorite 4, apatite 5, feldspar 6, quartz 7, topaz 8, corundum 9 and diamond 10. This is the highest hardness. So, no mineral exhibit more than